Yo, 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 yo. All right, guys. We are going to talk about solving quadratic equations. So we're going to learn multiple methods on how to do this. So this first section, we're just going to focus on graphing. We'll also look a little bit at tables as well. So we'll look at those two ways, actually. So two methods. First, quadratic equation, an equation with the second degree. And then zeros of a function are the solution to a quadratic equation when it is set equal to 0. The zeros of a function are the x-intercepts of a graph. And we're going to talk about what that looks like. So if I wanted to find the solutions to the quadratic equation, x squared minus 16 equals 0, then what I can do is I can graph this and figure out what are the x-intercepts of this particular equation. So I can graph it, okay? And then when I graph it, we'll look at the graph and find the solution that way. Because right now it is equal to 0, so that means I'm looking for the x-intercepts. So, we'll plug them in, we'll show why. So, first I gotta graph it, so I have to figure out, well, what is my, oh, sorry, there's like a lag there. There we go. I gotta find my vertex first. So I'm gonna go through the graphing this. I'm not gonna spend a crazy amount of time. That's 0. Oh, cool. So my x value is 0 for my, because that's 0 over 2 times 1, which is just 0. So x equals 0. So my axis of symmetry is here at 0, and then let's see, the y-intercept is negative 16, so it's going to be all the way down here, okay? Which is okay, because all I really care about is what the x-intercepts are. So now if I plug in 1, so if x is 1, so it's 1 squared minus 16, that's going to be 15, so it's again going to be down here on each side. But now if I plug in 2, this is when we're going to start moving. 2 squared minus 16, that's 4 minus 16, that's 12. We're getting closer. This graph is not ideal, but it'll work. It'll get to where we need to go. And then, let's see here. Now I gotta figure out what 3 is. So 3 squared, because we're gonna move a lot faster now. 9 minus 16 is 7, which we're officially on the graph. 4 squared minus 16, well that's 16, so that's gonna get me 0. I can stop here. So here's the graph. Uh-oh.
Hi, Stan Mowbray. Please come to the office. You are leaving. Hi, Stan. Please come to...
Okay. So there's my graph. So what we figured out is this particular graph crosses the x-axis at -4 and +4. So therefore, there are two solutions to this equation. The solutions to this equation are x equals 4 and x equals -4. Those x-intercepts are the solutions. Now, let's look and plug those into our equation so that we can see why that works. So if I were to go back and, here real quick, let's do this, there we go, erase this. If I were to plug this in, 4 squared minus 16 is 0, and this is equal to 0, right? So that works. It gives me the left side equal to the right side. Same thing with -4. -4 squared is still +16, which is also going to give me 0. So when I graphed it, I got two solutions, +4, -4, so I can write my answer as x equals 4, x equals -4. Another way to write that, when it works out so nicely where it's the same number, x equals positive and -4. These are two acceptable ways to write that solution. Okay, so now I might want to find the solution to this particular graph. So we know the y-intercept is going to be 49. So this is going to be, might be a difficult one to graph, might not be, but let's actually see what we can do. So let's see if we can find the vertex, and let's see if we can graph it. Go ahead and we'll find the vertex right now, actually. We'll do this one together. So we'll find the vertex. So the vertex, x equals negative b over 2 times 1. Oh, that means x equals, that's 14 over 2, that's negative 7, so x equals 7. So when I plug in 7 here, let's see what I get. So I get 7 squared minus 14 times 7 plus 49. Well, that's 49 right there. 14 times 7 is 98 plus 49. I'm going to get 0. So my vertex is at 7, 0. So when I graph this at 7, 0, that's right here. I know it's opening up. And I know my slope's 1, so my next is going to go like this. So my graph looks something like this. Okay. Well, I have the x-intercept. The vertex is sitting on the x-axis. So in that situation, when the vertex is sitting on the x-axis, there's only one solution to the equation, because that's the only x-intercept here at 7. So for this equation, the solution is x equals 7. When I plugged in 7, I got 0. So therefore, the solution is x equals 7. There's nothing else to do here. There's no other solution. That's the only one that works. And that's why the graph, the vertex is sitting here on the x-intercept, which gives me one solution. Okay, try this one on your own. See how you do. So pause it, try it, see what happens. I will then just show the solution to save time on this video. So pause it, try it. So here's the solution. So my vertex is here at, whoops. There we go, that's better. So my vertex is here at negative 1.5, positive 4.75. I know it's opening up because it's a positive. So I didn't really care about the other points because right away, if I notice, it's never going to cross the x-axis. So if it never crosses the x-axis and that's where my zeros are and that's the solution, that means there is no solution to this particular equation. So no solution to this one, I cannot solve it. Okay, pause it, try it, see how you do. We're going to do it again. Try another one. This will be the last one you try, then we'll look at some tables. So your graph should look something like this. So when I plug in -3, when I get my axis of symmetry of -3, I plug it in, and then I get 0 for my y values. That means it's sitting on the vertex, opening up, so there's one solution, and that one solution is x equals -3, because that is where this graph crosses the x-axis here at -3. So -3 is the only way to make the left side and the right side equal to each other. Now, you can also solve by using a table. Now, I don't know if this is the most efficient way. It works for some people though, so this might be a way this might be a way that you will like. So the way I can solve by using a table is, what I can do is I can fill out the table with the equation and find values until I get to figure out, and plug in values until I get y equals 0. Now the problem is figuring out the starting point of the table. You could find the vertex and start there. There's a few different ways to do it. Okay, so let me look at 0, and maybe I'll start at 0 on this one and just see where I'm at. So if I start at 0, because I'm going to want to go both ways depending on what I get. So if I start at 0, that's 0 plus 4, we know it's going to get me to 4. So what I'm looking for is my y values being 0, because the definition of an x-intercept is when your y values are 0. So that's what I'm looking for. So I got a y as 4. So that's actually fairly close. So now I can try numbers on both sides of 0. Well, I know if I plug in a 1, that's going to be all positive, so it's going to be more than 4, so I'm going the wrong direction. I want to go towards 0. So if I plug in -1, let's see if that works. -1 squared plus 5 times -1 plus 4. Let's see here, this gives me 1 minus 5 plus 4. That does give me 0. So -1 is one of my solutions. I have to find the other one. Okay, so now I'm going to keep going backwards and see what happens here. I can do -2 squared plus 5 times -2. And this is where you're going to have to fill out some values and do some math and see what works, right? Plus 4, so it's going to give me -2. So when I have -2, I get -2. Okay. Now when I plug in -3, I didn't need the equal 0 here. Sorry. When I plug in -3, I'm going to skip the math works. I've already done this. When I plug in -3, I also get -2. So I figured out this is when we're changing directions, so I have the same thing. The vertex is somewhere in between these two values. The axis of symmetry has to be in between these two. So that means my next one over is going to continue my pattern, and my next one over should be at 0. So I look at my pattern here. Went to 0 to -2, back to -2, so it should go back to 0 based on the axis of symmetry. So, -4. So my two solutions are x equals -1 and x equals -4. Now again, the table sometimes works, sometimes doesn't work. It just depends. If you like it, it works great. If you don't like it, it might not be the best. Okay, so again, for this one, use a table, try it, see how you do. And then I'll have the table ready for you, and that way we don't have to watch me make it. So here's how I made my table. What I did is I started from x equals 0, got -6. Notice that it's counting up, getting closer to 0, so I got to 2. And then when I plug in -1, I noticed it's starting, I also knew I would keep going up, because I know this graph is going upwards. So, and the y-intercept's down here. So just by knowing that, I knew I had to go on the other side of 0. So that's why I tried -1. I realized it was the same as this one. So that means there was my axis of symmetry was in between -1 and 0. So now I can just continue the pattern. So x equals -3. Okay, that's all I got for you guys. No things to remember this time around. And solve this one. I got a graph for you if you want to do it that way. If you choose to do a table, that's okay. And that's it. Thanks for watching. If you guys have any questions, let me know. Good to see us out.